Alright, so let me go ahead and start a recorder. I guess I already had one, but I wasn't actually recording all of that, so I just turned on my recorder now. Alright, cool. So nice work, everybody. Again, PA4 was you know, hopefully an interesting project. A fairly large project in some ways. I mean, it has lots of parts and pieces. If you did it in a group, it may have been, you know, a smaller piece that you were working on. But you know, putting these things together and getting this whole, you know, kind of working single function program at the end, hopefully that's pretty fun for a lot of people. And nice job on the presentations. Talking in front of other people, is one of those skills that kind of has to get developed sometimes. Some people are very natural with speaking in front of others. Some people are terrified of it. And it gets easier over time. And one of the few upsides of you know, all this remote teaching stuff that we've had is doing presentations has been, you know, a little lower key, a little less stress for some people because you're not facing a room full of faces staring at you, you know. But it gets easier with time, and I think people are doing a great job on this. So, so nice work across the board. Let's see, is the Linux server currently using mock? I do not know. But all of this code, you should be able to download and install a local version of different versions of this and experiment with it. But let's see. So awk is currently mock, yeah. So gawk is not. See if this works. So apt is the package manager, one of the package managers for Linux, and basically apt install will install a package from a code repository. And so if I want to install gawk, I can say apt install gawk. I'm saying sudo because you need to be an administrator to do this, otherwise anybody could install anything. So this is saying super user do package manager.
We can't see your screen, by the way.
Install gawk. Oh, I'm not sharing. Oh, where'd my window go? Well, anyway, I'm installing awk. Oh, there we go. Alright, so this is one of those where the video is going to make a lot more sense than the live. So, so sudo apt install is the general way in Linux that you install packages. And so I'm installing gawk, which is a different version of awk that apparently has more memory available. So if I say awk, now it's going to run gawk. But it should work basically the same. All right, cool. Sort some big stuff. All right, so let's talk about associative arrays. This is one of the main keys to working with PA5. So remember, PA5, our basic setup is we've got three main sections to our program. The first is reading in your input from standard in and breaking it into a series of phrases, basically things separated by punctuation marks. and doing this in a way that our phrases all look kind of the same. So they're all going to be uppercase. We're going to get rid of things like parentheses and so on and so forth. So first part of PA5, we're just getting phrases. We're taking your input, phrase, 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 phrase. The second part is we want to record how many times we've seen each of these phrases. So we're going to use something like an array to store our phrases and record how many times we've seen them. And then third part is to go through our set of stored phrases and just print it out. So we talked about cleansing yesterday, and we'll play more with sed and stuff like that today and tomorrow. But let's talk about the second part of this. Suppose you have a phrase and you want to tally it. You want to record that you've seen it, and the next time you see it, you want to record that you've seen it twice, and so on. And so we're going to use a concept called an associative array. An associative array, and this is also sometimes called a hash table. And so you know, in C, I can make an integer array x, and I can say this is an array of 10 elements. And I can say x bracket 0, x bracket 1, x bracket 9. And each of these is a separate integer, and I've got a total of 10 integers stored under this one variable named x. And in C, you know, I could actually say, let's look at x bracket 5000, and it will do something. It might segfault my program. It might, you know, give me some weird random value. But this is not really, you know, an appropriate thing to do in C if our array has been declared to hold 10 elements. So when we say x bracket something, this thing we're using to pick out an element, this is called the index. And in this case, where we have an array of 10 elements, our index has got to be bigger than or equal to 0 and less than 10. Somebody just sorted the Bible in 12.7 seconds. So if you put that into sort-n and look at the end, you should be able to see the most common phrases. Alright, so this is a plain old array. This is what we're used to in C and other programming languages. An associative array is the same idea with one small but powerful twist, which is that this index doesn't have to just be a number between 0 and 9. It could be something like a string, hello. It could be 5,000. It could be negative 2.7. It can be anything. Any collection of characters constitutes a valid index for referring to an element of this associative array. So ponder that if you haven't encountered this before, right? We have an array of perhaps integers, but we can access the elements of this array using indices other than just consecutive integers starting from 0. We can access it with other integer values. We can access it with things that aren't even integers. We can access it with things that aren't even strings, aren't even strings of digits. So what this means is we can start to make an array that associates things with each other. So if I have an associative array called, let's just call it mem, I can say mem bracket Nick equals, and I could store something associated with Nick. And I could store mem bracket Izad, and I could store something associated with Izad. And so these are all perfectly legitimate indices. And so, for example, you know, if I wanted to record, you know, what class I was teaching, I could say mem bracket Nick equals quote CSE224, CSE215. And mem Izad might be, you know, engineering 204, and I don't know if he's teaching 101 this quarter or not. Right? And so you can use this however you want. But the power of it is that, you know, the way we would normally do this in C is we would make a pair of arrays. We'd have an array of names and we'd have an array of data. And if we wanted to find the data associated with Nick, you march through your name array one by one and you look for Nick. And if you find Nick in element, you know, 117, then you go through your data array element 117, that's the data associated. In this case, we can actually use, you know, a name, for example, as an index into an array. And this is a common data structure in computer science. It's also known as a hash. We will dig into the mechanics of how hashes work and actually code them ourselves in C in winter quarter in CSE222. But for now in Bash, we just need to know that we can create these associative arrays and we can use them to access information associated with something else. And this, by the way, is how people think our minds basically store information. We're pretty certain that our memory is not just an array. We don't have, you know, like a sequential array of memories, memory 0, 1, 2, 3, 4. That would be horribly inefficient when you catch a whiff of a smell and you want it makes you think of you know, a summer day when you were 12 years old. That doesn't happen by going through an array of scents and finding one that matches and then looking through the array of memories, you know, for summer days. There's something more complex going on in our minds, and it seems to be something that, you know, links data to data. So here's one piece of data, and associated with that is another piece of data, and associated with that is another piece of data. And our memories seem to be stored in something more like an associative structure, as opposed to just kind of, you know, linear storage. And so we're going to take advantage of this in PA5 by making an associative array. We can think of it as being called tally. And our indices are going to be the phrases that we find. So when we find a phrase, you know, from part 1 of PA5, which says, "This is fun," we're going to use that as an index into this tally array and see how many times we've seen this phrase. And if we've never seen it, we're going to set this equal to 1 to say, hey, we've seen this once before. The next time we encounter this phrase, we're going to look in our array and we're going to say, hey, we've seen this once before. We're just going to increment that to a 2. And the next phrase we see maybe is something like, you know, good day. And maybe we've seen that 5 times. So we'll use that phrase, look up the tally. Hey, we've seen it 5 times. We'll increment that to 6. And so yesterday, you know, we cleaned up input, we broke it into phrases, and we left with kind of a loop that you would run to break your input into phrases and pull them out one at a time. So we ended with something like this. So for a phrase and phrases, do whatever you need here. This is the whatever you need here part, right? Your goal here is to take this variable. That's a phrase, see if you've seen it before. If not, save it with a count of 1. If you've seen it before, increment the count of how many times you've seen it. So that's what this is all about here. Alright, so we got to go through the mechanics of how we do this in Bash, but does everybody get the basic agenda here? This idea of associating 2 pieces of data. Alright, so let's see how this works in Bash. So if I want to declare a simple array, I can just say declare simple. And it just makes, you know, plain old array. And I can store values in here. If I can type. Right? And you know, this looks like kind of what we do in C, right? We have the name of the array, bracket, and an index. And you know, if I have some index like I, which is equal to 4, I can say simple bracket $I, and this is element 4. All right, to retrieve things from an array, we have to use a little bit of a funny syntax. So I can say echo $curly bracket simple bracket 0. And there's element 0, here's element 1, here's element 4 that we put in using a variable for the index, here's element 5. If I look for an element that hasn't been saved, it just comes out as an empty line. And so there's you know, no sort of inherent length to this. We don't have to declare this is going to hold 10 things or 10,000 things. We can keep, you know, storing elements. So that's a plain old simple array. Okay. To make an associative array, we use the -a switch. So let me call my array tally. So you know, I can still use this like a plain old array, and I can see what element 0 is. But I have the ability to use non-integer, non-consecutive indices. So I could say tally bracket, this is fun. And if I'm building my tally of you know, phrases I've seen, maybe I've seen this is fun, you know, 5 times. And maybe I've seen, you know, hello, goodbye once. And so if I want to know how many times have I seen the phrase, this is fun, I can just look at $curly tally bracket, this is fun, and there's my tally count, 5. All right, so we're inside our for in loop from yesterday where we're getting phrases, right? And so let's say our phrase was very cool. So if I were to echo $curly tally bracket $phrase, I get this empty line back. And so we can say something like you know, count equals that thing. And so count tells me how many times I've seen the phrase very cool. Now if I do my usual count equals $count plus 1, my usual trick, and I echo count, now it's equal to 1 because an empty line gets interpreted as a 0. And so now if I set tally bracket $phrase equal to $count, I've recorded now that I've seen this phrase once. And now if I echo tally bracket phrase, it's got a 1 in it. Now if I say phrase equals this is fun, and I do the same thing, count equals tally bracket $phrase, my count is 5, telling me I've seen this phrase 5 times. I increment my count. I save my incremented count back into my tally array. And now if I look at how many times I've seen this phrase, tells me I've seen it 6 times. Oh, thank you. Bonus.
So is this program that's literally running through the for loop is running through the whole thing and tallying up each individual one, and then for the next one it'll increment to the next phrase and then check the whole thing and print that out? Is that basically what the program is doing?
You mean
like scanning the whole document?
You mean PA5?
Yeah.
So for PA5, you're going to read in your input, clean it up, break it into phrases, and each phrase that you pull out of your input, you're going to do something like this, right? You're going to go into an associative array, see how many times that phrase has been seen, save that in a variable, increment it, save it back into your tally. Is that what you were asking?
Yeah, so basically the for loop is it's gonna check the first phrase, it's gonna go through the entire document, tally that up, print that out, and then it's gonna increment to the next phrase, right? And then go through the whole document, check that.
No.
That's basically what the loop is. No?
Nope. So you're
Okay.
going to something like this. So
trying to think what the flow is gonna be of the program.
So read a line of input for each phrase in that line. Update your tally array. And do this for your entire set of input. So you're going to probably have like a while loop that keeps reading lines of input from standard in. And for each line, do the stuff we did yesterday, break it into a set of phrases, use your for in loop to pull out the phrases from that line one at a time. Each phrase, just update your tally count. And this update is could be 1 line of bash, could be 3 lines the way we've been doing it in here, where we read the count, we increment the count, and then we save the count. But there's no looping for doing this update part.
Okay.
Right? That's sort of the power of the associative array. All right, so this is the heart of the second part of PA5. All right, this is the whole tallying thing, and we don't need to, search the array for the phrase to find what the tally is. The real magic is we can use that phrase as an index and go directly to whatever value we've stored associated with that index, which for us, those values are going to be the number of times we've seen the phrase. All right, and then the third part of PA3 is printing the tally at the end. So after we've finished this loop, after we've gone through all of this and built up the tally, then we want to print the tally, which means basically just going through all the phrases that we've saved and printing out the phrase and the number of times that we've seen it. But there's a detail here, right? If we have an array that's just a plain old array and we know it's got 10 things in it, we can just say, for I equals 0 to 10 or 0 to 9, print out, this element of the array. But in this case, our array is indexed by these phrases, and if we don't know what these phrases are, how are we going to be able to pull them out from the array? So we need a way to know what the valid indexes are on this associative array. And so this is a really peculiar bit of syntax. It's peculiar to me, at least. If we echo $, curly bracket, exclamation mark, name of the array, bracket, @, that will give us a space-separated list of indices. All right. and this thing, don't try to make sense out of it, or you don't have to make sense out of it, right? It's just the way that Bash says, hey, here's an associative array. Give me a list of all the indices separated by spaces. That's what this is. So in this case, I can see I've got 4 indices. Very cool. 0, which we did in the beginning. Hello, goodbye, and this is fun. And they're separated by spaces. And if you're storing your phrases without spaces in them, right? And remember, we're changing our spaces into underscores. So if we're storing our phrases with underscores, then each thing separated by a space is a separate phrase. So now I can put this inside a for in loop. So for p in $ curly exclamation mark tally bracket at do right. And remember, for in says, right, go through this string and break it up into things separated by spaces, and each time through this loop set p equal to the next thing separated by spaces. So if I inside here just say the next phrase is $p, this shows me my 4 valid indices, my 4 phrases that I've saved. So if you do this without the exclamation mark, you get the values instead of the keys. You get the things that are stored associated with each index. And someone just said in chat that's a pretty standard notation for associative arrays in other languages, so that's cool. So here's a way to loop through and pull your phrases out. And once we know what the phrase is, we can, of course, pull out the tally value associated with that by just going into the tally array. So I could modify this a little bit. I could say, let's print out $ curly tally bracket $p. And so now I'm going to, inside my loop, say next phrase is $p. I should not have used a number sign because that's a comment. Well, I'm in a quote. That should be okay. Number of times that occurs is, I'm going to do tally bracket $p. So I'll use that phrase as an index into the tally array and print out the value stored with that phrase. And so I can see, you know, this was fun was in there 6 times. Hello, goodbye was once. Very cool was once. And that's pretty much the third and final part of PA5. So part 1, you do what we did yesterday. You read your input from the file, you clean it up, you break it into phrases, and then you do this. Right, each line that you've read and cleaned up is a bunch of space-separated phrases. You do this, and right here, at this point of this do loop, you've got a phrase in this case, the variable phrase. So now we store that into a tally, right? And that's what this is talking about, right? The key, the thing we're going to use is an index is the phrase, and the value we're going to store is the number of times the phrase has appeared. So read the current tally, increment it, store it back. And if the phrase has never appeared before, when you read it, increment, you'll automatically end up with a 1. And so you store that 1 back, and you've got the count. And then after all of that's done, you need to go through and print out the contents of the array, and that's basically just another for loop. So for phrase in, and here I'm using the name count for the array instead of tally. So for each index in this associative array, and we'll just output the index and the number of times it occurs. And when you do your output, make sure you replace the underscores with spaces at that point, so that you don't get a phrase with goofy looking underscores in them. So that's pretty much everything you need for PA5, with one really minor detail that I forgot to mention yesterday, which is how to detect the end of a file inside Bash when you're reading, and that's pretty painless to do. So let's make a read loop program. All right, so here's a forever loop that reads an input line, echoes it, and keeps looping, and it's never going to finish. Oh, I made a typo too. Read line. Right? But if I hit Control D to try to signal the end of my input, it just comes out as an empty line. And so if you want to detect that you've hit the end of your input, what you can do is you can check $?? Right? So $?, remember, shows you the status of your previous command. So if you succeed in reading a line of input, $?? will be 0. If something goes wrong, such as hitting the end of a file, $?? will be not equal to 0. So here I'm going to say read line until the status is non-zero, at which point we'll break out of our loop, and then we'll say we're finished reading. So hello, ABC, cool. And then if I hit a Control D, that takes me out of my loop. And if I do read loop and I redirect from, say, a file, like, read loop, it will read line by line, but when I've hit the end of this file that I'm reading, that read line will set the status equal to non-zero. And so this if statement will kick me out of the loop. So you can put that for something like that for your main loop that's reading a line of input. And then for each line that you read, do the stuff yesterday, convert to uppercase, break into phrases, and so on. And then loop through each phrase in that line, do the tally updates that we've been going through today. And then when you're done with all of this, after you've hit end of file and broken out of your read loop, make your for loop to print through the tally of each phrase. Let's see, would it be possible to have PA5 due on Saturday because 24 through 6 is break? Fair question, but I'm going to say no. That's part of why I started the assignment yesterday, so that, if you want a full week to work on it, you would have from yesterday until, the day before break starts, and then if you need extra time, you've got that extra Wednesday, Thursday, Friday. I'm not actually expecting people to work on Thanksgiving on this assignment. I'm sort of anticipating that people will finish it, before Thanksgiving, if you want the break. But then I need the time on Friday to grade it, so I'll stick with that due date. All right. Other questions? So we're going to start talking about SED a little more tomorrow, and we'll talk about something called regular expressions. But part of this processing of your input to clean it up and break it into phrases and stuff, you're going to make good use of SED. And, you know, the way we've been using sed is basically like this. So we can say substitute, for example, a space with an underscore. And then if I say this is a test, it turns it into something that doesn't have any spaces in it anymore. And if I say this is a test, right, I get these really long collections of underscores. And so I mentioned yesterday, if you search for not just a space, but a space followed by space asterisk, that will take things that have multiple spaces in them and compress them down to a single underscore. And that's a little easier to deal with. And then if I take this phrase and I put it into sed to change my underscores into spaces, then I've got back, you know, a phrase with nice space separations. But if I have a phrase with, like, you know, spaces at the end, I've got an extra underscore at the end, which I may not want. So there's other things we can do with sed. And we'll start tomorrow by talking about these, but a few things we can do. One, we can do this business of you know, something followed by an underscore to say, hey, match 0 or more of these things. So when we search for a space asterisk, not underscore, asterisk, we're saying look for a space followed by any number of consecutive spaces after that. So if there's 5 spaces, those will all get matched by this. So that's one thing we've seen. We can also say something like dot to say match any character. And we can also say, let's match a character at the beginning of our input string, or let's match a character at the end of our input string. And so, for example, if you want to get rid of spaces or underscores in the beginning of a string, we can do that pretty easily by using a caret. And so this is an entry to a larger topic, which is the notion of regular expressions, or regex. And we'll start from there tomorrow and play around with that for a day, and maybe have some ODPs about that. Who knows? But that's gonna lead us into a deeper discussion of sed. But what you've got right now, you should be able to do PA5. It takes a lot of work. You got to put the pieces together in the right way, and you're going to have to do a lot of trial and error probably at the command line. Hopefully, you know, doing these kinds of things, typing, you know, statements and trying them out and seeing what happens. And at the end of the write-up for PA5, this section near the end talks about some sample code that can help you. Right, so here's, you know, an example of declaring an associative array. Here's setting values. Here's pulling values out of the array. Here's iterating over all of the indices. Here's using an index to access a value from the array, right? And that's probably all that you need to know about associative arrays for PA5. It's going to be some combination of things that look like this. So you've got the tools, right? It's a matter of structuring it and figuring out how to use these, and definitely do that, you know, at the command line. Take an input line, and now it's stored in, you know, a variable $ line, and just play with that. Take that and pipe it into TR. See if you can convert it to uppercase. Take the output of that and pipe it into sed and see if you can get rid of special characters and so on. All right, so we're out of time here. Send me an attendance ping on the way out, please. And have a good one, and I will see you next time.
Thanks. Do you remember if we had an initial attendance ping?
Oh, I don't know. Send me one now, and you're good.
Oh, okay. All right. Have a good day.
All right, thanks. You too.
Just a quick question. So when we pipe stuff, it's sequential, right? It does the first thing, then the second thing, and the third thing.
It'll run them all in parallel, actually, but the second thing won't do anything until it gets input from the first thing usually. But if you're doing, you know, something on a bunch of lines, each time that your first thing outputs a line, your second thing will do something with that, and so on. So it's more or less in parallel.
Okay.
All right.
I was thinking, so like if I took the, you know, I set it something to remove the spaces, added the underscores and something else, and then I could take the underscores back out and put spaces back.
Yeah.
That would typically work.
Yeah, totally.
Okay.
All right, cool. See you later then.